Hello, calculus students, and we are going to talk about the second practice exam. Now, the first question here, you're given a table of values for g and g prime. It says that the functions f and g are twice differentiable, and values of g and g prime are given, and the function f of x is defined as 2 plus integral from 0 to 3 of g of t dt. And first part A, explain why there must be a number c between 0 and 9 such that g prime of c is 1/3. Okay, so you should know right from seeing that you're going to want to use the mean value theorem because it gives us a derivative equal a number on some interval. I should mention before I start, since I was given f and I knew I would need f prime and f double prime later, I went ahead and wrote out f prime and f double prime. So the first derivative, use the Fundamental theorem of calculus, derivative 2 is 0, and then just plug in the 3x for the t, so it's g of 3x, but the chain rule says multiply by the derivative of 3x, which is 3. So this is f prime of x. And then f double prime of x, do the chain rule again, it's going to be g prime of 3x times 3, which gives you the 9 out in front. Okay, so on to the part A then. Show that the slope equals 1/3 somewhere between 0 and 9. Now, if you notice, the interval 0 to 9 will not give us a slope of 1/3, but any subset of that will work. Okay, so we want to use the values of g between 0 and 3. Okay, so show that g of 3 minus g of 0 over 3 is 1/3. Okay, so that's the first thing to show. And then you must state since g is continuous and differentiable on 0, 9, which also means it's continuous and differentiable on 0, 3. By the way, it's not good enough just to say it's differentiable. You must also say it's continuous. I noticed not all of you did that in your work. You have to say both continuous and differentiable. Then there must be a c between 0 and 3, such that the derivative of c is 1/3 by the mean value theorem. And once again, since 0, if it's between 0 and 3, then obviously it's also between 0 and 9, which is what I was supposed to be show. All right, part B, evaluate this integral. All right, so this was a challenging problem. There's a lot going on there, okay? Integral 0 to 3 at 40 times f triple prime of x dx. All right, so you had to start using integration by parts, which I think everybody did from what I remember looking at your work. Integration by parts. You got your u and your du, your dv, and your v. So rewrite it as u times v minus the integral of v du, evaluated at 3 and at 0. Okay, so now we do the plug in 3 and plug in 0. Here's what I did, here, and then do the antiderivative of 40 times f prime. F double prime is 40 times f prime, plugging in 3 and 0. So now these values come from what I said at top, right? F double prime of x is 9 times g prime of 3x, and f prime of x is 3 times g of 3x. So f double prime of 3 is 9 times g prime of 9, and then plug in 3 and 0, f prime of 3 is going to be 3 times g of 9, and then f prime of 0 is 3 times g of 0, and then take the difference, multiply it by 40. Okay, so plug all those values in, and you end up here. This is 810 minus 40 times negative 3 over 20 plus 6. All right. And of course, you can stop once you get to here, or if you simplify, you end up with 576. Okay. By the way, you cannot stop here. You always have to plug in the numbers. Okay. You have to plug in the numbers. It's just the arithmetic you don't have to do. So this or this or this, any of those are correct answers. All right. So that was the integration by parts for part B. Now, part C, use a right Riemann sum with 3 subintervals to approximate the length of the curve from 0 to 9. All right, so this is a little different. We've done right Riemann sums with area under curve, but never the length of the curve. So if you remember, the length of the curve is the arc length formula is here. It's the integral of the square root of 1 plus the derivative squared dx. Okay, so this time I'm going to be using this 3 times on over 3 intervals, 0 to 3, 3 to 5, and 5 to 9. And I'm going to use these values as my g prime, right? I need a g prime in there. So I'm going to use the radical 8, the radical 3, and the 3/4. So that's what I did here. I did the width times square root of 1 plus the derivative squared, plus this width of this interval times the square root of 1 plus the derivative squared, plus the width of this interval times the square root of 1 plus the derivative squared. And you end up with 9 plus 4 plus 5, which is 18. So that arc length approximation is 18. So similar to what we did with the approximating areas by rectangles, now we're approximating the arc length by using basically the hypotenuse of these three triangles is really what we're doing there. Okay. Um, D, your Taylor polynomial. Let P sub n denote the nth Taylor polynomial for f about 0. Find the P sub 2. So find the second degree Taylor polynomial. So we need at 0. So we need the f of 0, f prime of 0, and f double prime of 0, which once again, just plug it in what we know about f prime of 0 is 3 times g of 0, f double prime of 0 is 9 times g prime of 0, and f of 0 is 2. That was given. Or it wasn't given, I'm sorry, but you do the integral from 0 to 0 is 0, so that's just going to have 2 plus 0, which is 2. So that's where I got that from. All right, and then you plug it in the Taylor polynomial formula. Remember, the second derivative is divided by 2 factorial, and you end up with 2 minus 6x plus 18x squared. That's your second degree Taylor polynomial. And then part E says to consider a geometric series whose first three terms are defined by the polynomial in part D. Find the sum of the series when x equals 1, 6, or show it diverges. Okay, so we had a lot of trouble with this one. Again, it was asked differently than you're used to seeing as far as geometric series. But you wanted to use your answer from D, and now remember, D is a polynomial. There's x's involved, right? So for E, they want us to find the series when x is 1, 6, right? The series when x is 1, 6. And then tell me, does that series converge or diverge? So what I did is so we have this geometric series of this infinite sum, where these are the first three terms. But I want to find the value when x is 1, 6. So I plugged in 1, 6 for x, and notice the pattern. You end up with 2 minus 1 plus 1 half. Okay, so look at that sequence. That is a geometric series. That is a geometric series, all right? With your first term being 2 and your r being negative 1 half, right? You're multiplying by negative 1 half and by negative 1 half, et cetera, et cetera. So it's a geometric series with a is 2 and r is negative 1 half. And since epsilon of r is less than 1, it converges, and then the sum is simply a over 1 minus r. Okay, so this is a case where I think it was helpful to plug in the 1, 6 and write it out like this, not leave it in terms of like your x's, which some of you tried to do. Okay, so write it out just as a geometric series with numbers, and then you can find the sum. So that was part E from question 1. Okay, now moving on to question 2. I think this was definitely the more challenging of the two. In fact, I even think this problem took a little bit longer. I know this was supposed to be only 15 minutes compared to 25 for the first one, but some of the integrals here definitely seemed like they took longer. So anyway, let's talk about this. The function f is twice differentiable, gives you f of 3 is 7. The graph of f prime is shown above. And notice it says from 1 to 6, f prime is a line segment. And if you look at the graph, it appears to be a straight line from 1 to 6. That's going to be important later. Okay, so again, you can't assume it, but since it tells you it's a line segment, we know that. And the function h is defined as 2x minus 5. Okay, so part A, okay. This was hopefully an easy one. Just find the derivative of g at 2, where g of x is f of x squared minus 1 times h of 2x. So just doing the product rule, u dv plus v du, okay? Just, again, be careful with the chain rule. Each time you do the du and the dv, do the chain rule. And then plug in 2, okay? And you can get f of 3 and f prime of 3 from the graph. Or I'm sorry, f of 3 is given. F prime of 3 is you get from the graph, and then h of x and h prime is using the 2x minus 5 that's given there. Or yeah, 2x minus 5. All right, and just plug in the numbers and you get 52. Okay, so again, hopefully that part wasn't too difficult. All right, now on to part B. Given this integral equals 22/3, find f of negative 1. Okay, so you know, if you do your work correctly, this integral should come up somehow, some way in the problem. All right, well, this looks like a fundamental theorem of calculus problem, right? I have a derivative of f and I have a point. I want to find another point. So that's how I would start it first. Okay. That f of 1 is f of 3 plus the integral from 3 to negative 1 f prime of x dx. Okay. So start with that first. Start with that first. Use it from a theorem and calculus problem. Okay, how do we figure out this integral? How do we figure out this integral though? Okay, well, that goes back up to what you are given. Okay, you were given that this is 22 thirds. Okay, so what I did, and I hope you would do that as well, plug in the 2x minus 5 for h. You're going to see that later. If it tells you h of x is 2x minus 5, plug that in. That helps you visualize. You can see, oh, that's a u substitution. Right, there's your u, there's your inside function. You can see that a little better when you write it inside there. So that's your u, and then you got a du. And don't forget, since it's a definite integral, make sure you change these limits of integration to u values. So plug in 2, plug in 4, you get -1 and 3. So what do you end up with? Now we need to multiply by 2 inside to get our du, so we put a 1/2 out in front. So this integral ends up being 1/2 integral -1 to 3 f prime of u du. That is equal to 22 thirds. So this integral here equals 22 thirds, because that's what I was given in the problem. All right. Now, notice I have this integral. Hey, that's kind of what I want, right? That's where this is going to show up. This integral is what I want. I need to get this by itself, so I'm going to multiply by 2. So this integral by itself, -1 to 3 f prime of u du, is 44 thirds. All right, I know that from the information given. Now go back to here. Go back to your fundamental theorem of calculus. If this integral is 44 thirds, flip the a and the b, this integral is -44 thirds. So my answer is 7 minus 44 thirds, or -23 thirds. Okay, so it's a case where you had to sort of take two different things and combine them together. Start with this fundamental theorem in calculus, and then go to what you're given and manipulate with your substitution to get this integral that you can plug in. Okay, so that was part B. Part C, evaluate this integral, 1 to 5 f double prime of x times h of x. Okay, um, once again, I would plug in 2x minus 5 for h of x, so you can visualize this a little better, right? And now we have integration by parts. Again, most of you noticed that, at least to start off with, because you've got a product there. There's your u and your du, and there's your dv and your v. Right, the antiderivative of f double prime is just f prime. Okay, so now write it out using the integration by parts formula, uv minus integral v du. Okay, so I need to find this integral, 2 times f prime of x. Now remember, I don't have a equation for f of x. Okay, um, but I can find it. There's actually two ways you can do it. Okay, you know the graph of f prime, and from between 1 and 6, it's a straight line. So you can use the area under the curve to figure out this integral. All right, take the 2 out in front. That's what I did. Take the 2 out in front, and I want to find the integral from 1 to 5 of f prime of x dx. Well, go back up to your graph, right? If I draw a vertical line at 1 and at 5, it's just going to be this triangle minus this triangle. Okay, um, so go back up to, where's my work? Here we go. Come back up to here. This integral is 8 using the area under the curve. Or secondly, you could have found the equation for this line, right? We know that, again, f prime of x is a line segment from 1 to 5. The equation for this line, well, the slope is -2 and the y-intercept is 8. So it's -2x plus 8. Now come up in part D as well. I'm going to use that in part D. But you could have done that here. You could replace this with -2x plus 8 and then just done the antiderivative and plugged in your 1 and your 5 like you normally would. In any case, and then f prime of 5 and f prime of 1, again, you get those values from the graph, and you end up with -8. Okay, so as again, it's integration by parts, but there's a little twist to it. You had to use the graph to find this area. Uh, in other words, to evaluate this integral. All right, part D. Okay, this one definitely confused a lot of people. We've got integral from 1 to 2, 6x over f prime of x times h of x. Okay, so when you see something like this, you should probably think partial fraction expansion. All right, because you've got a product, you've got two different factors in the denominator. All right, now plug in what you know. Again, some of you were trying to solve this using f and h. All right, if they give you an equation for h, 2x minus 5, always plug that in. You're more used to seeing it like that. I think you're gonna be more comfortable what to do than just with h. Now, what about f prime of x? Okay, that's what I said a moment ago. Go back to f prime. From between this interval of 1 to 5, it is a line, the line -2x plus 8. So that's what you want to do. You want to also replace f prime of x with -2x plus 8. Okay, so now it should definitely look like partial fractions, right? I've got two different factors in the denominator, and again, there's no u substitution or anything that can help us out, or integration by parts. I have to do partial fraction expansion. And again, the derivative is negative 2x plus 8 on the interval from 1 to 6 based on the graph. So that's what you want to do with your partial fractions. Take this and break it up as a over negative 2x plus 8 plus b over 2x minus 5. And I didn't show all the algebra, but I know you can do that. Um, you solve for a and b, and you get a is 8 and b is 5. Okay, so now I'm going to rewrite it as this integral 1 to 2 of 8 over negative 2x plus 8 plus 5 over 2x minus 5 dx. Do the antiderivative. Don't forget, here you have to multiply by negative 1/2, and here you have to multiply by 1/2 because of the negative 2 and the 2 in front of the x. And then plug in your 2 and your 1, okay? And you get all this nasty stuff here, which again, you can leave like this. You don't have to simplify, okay? But if you want to simplify, L in the 1 is 0, right? That goes away, okay? And then you can combine or distribute the negative and bring the 4's together here. 4L in the 6 minus 4L in the 4. Well, remember when we subtract logs, we divide inside the logarithm. So 6 over 4 becomes 3/2, and then minus this, okay? But again, you don't have to simplify. You could have stopped at this line. That would have been okay. So that was a partial fraction problem, okay? And one more time, though, I think you want to write it like this. Write it like this to recognize what to do, okay? So if they tell you h of x is 2x minus 5, replace that. And if you know f prime of x, again, replace that with the linear equation, and then you'll know better what to do there. All right. Part E. The function k has first derivative of that. Is known that k of 1 is negative 1. Find the third degree Taylor polynomial. All right. This one, though, also should not have been too difficult. All right. First, you just had to find k of 1. Well, you're given k of 1. Find the first three derivatives. But just use this formula. K prime is f of x plus 2. So that you're given. So k prime of 1 is f of 3. K double prime of 1 is f prime of 3. K triple prime of 1 is f double prime of 3. And again, you get these values from the graph. Okay. And then just plug in your Taylor polynomial. Remember, the second derivative is over 2 factorial. The third derivative is over 3 factorial. And if you simplify, you don't have to, but 2 over 2 is 1. 2 6 is 1/3. And there you go. There's your third order Taylor polynomial, about 1. So again, that shouldn't be too bad. All right. Definitely want to make sure you know your Taylor polynomial formulas, because I think we've seen that on almost every one of these for response, and I'm guessing that will probably show up somewhere on yours as something from the series chapter. Okay. So I will post the solutions as well that you can look at yours. Go back and so if any of these problems you missed, please go back and try those on your own, and then check the solutions that I posted. And I'm going to give you some more problems to work on over the weekend as sort of a final review before the AP test next Tuesday.